So in this section, we're going to be classifying three-dimensional figures. Here's the deal, and it may seem silly and simple, but if you're not an expert at naming your shapes, it's very difficult to figure out how to find the surface area and the volume because everything stems from your base. So you have to understand, what does it mean? What does a big B mean? What does your base mean? And it all comes from naming the figure. So if you look at prisms, we have a solid with two bases that are congruent and parallel. So look at my bases. I've got this base, which is a triangle, and the same shape is going to be opposite and congruent. So the only two figures that are opposite of each other and congruent are these triangles right here. So this is a triangular prism. And here's the deal about your shapes. When you have a prism, the bases, big B, this stands for big B. That's your area of your base. And that's a big B, okay? So big B, that's my base. Your lateral area is around that shape. That's your lateral area. And your lateral area on a prism, those shapes are always going to be rectangles. Okay, those are going to be rectangles. Now, prisms are different than pyramids, right? A pyramid, you have one base, and they come together at the apex, okay, or a point and apex. So the lateral area on your pyramid, look at these figures. These are all triangles. But when you're naming the pyramid, you name it by the base. The same way you do a prism. You name it by what the base shape is. So this guy, triangular prism. This guy, triangular pyramid. You name it by the base, the big B, okay? Now, cylinder clearly is different. Cylinder, cones, and spheres, they're all different because they have that round area. So a cylinder, it's really a prism with a circle as a base. But we just call it a cylinder. Interestingly enough, if you were to unwind, if you were to cut this cylinder and make it flat, your lateral area is still a rectangle on a cylinder, okay? Your cone. A cone is just it's a specific pyramid that has a circular base. And then a sphere, of course, is a solid in which each point is equidistant from the center. Okay, so all these points are equidistant from the center. All right, so when you're looking at these shapes, let's name them. And I want you to highlight the base. So here, my base is a rectangle. So this is a rectangular pyramid because it comes together at an apex or a point. This guy is a cone. You have a circle for the base, so it is a cone. Number 3, look at my base. The two shapes that are opposite and parallel to each other are triangles, so this is a triangular prism. Okay? Number 4, what kind of shape do you have here? You have 1, 2, 3, 4, 5, 6 sides. So a 6-sided shape is called a hexagon. So this is a hexagonal pyramid. Okay? All right. Look at number 5. You have a circle as your base. So this is Spechendel, and we just call this a cylinder. All right, if you look at number 6, I've got this rectangle down here. So this is a rectangular prism. All right, let's look at number 7. Now, remember the definition of base. It's two sides that are opposite and congruent of each other. So even though this guy is not lying on the right side where we think of base, the only two shapes that are parallel to each other and congruent is this trapezoid and this trapezoid and back. So this is a trapezoidal prism. Okay? All right, number 8. What is this shape down here? All sides are congruent and 90 degrees. So this is a square pyramid. number 9, my base is 5-sided, so this is a pentagonal prism. Okay. Look at number 10. Comes together at a point, and the base is a triangle. So this is a triangular pyramid. All right, look at number 11. Definition of a base is the sides that are opposite and parallel to each other. So the shape that's opposite and parallel to each other is going to be this triangle and this triangle. So this is a triangular prism. And of course, number 12 is a sphere. Sphere. All right. So let's look at slicing 3D figures in the same video. All right, so if you flip your paper over, when you slice a 3D figure, you're looking at a cross section. That's what that's called. And it's going to be a 2-dimensional figure, right? 3-dimensional. It has, 3 dimensions to it. It's got the base, it's got the height, it's got the volume. So when you slice a 3D figure, it becomes 2-dimensional. It becomes flat. For example, when a cone is sliced parallel to its base, then the opposite cross section is going to be a circle. Let me widen this. Much better. So if I look at cross sections here, so if I were to cross this in half, this resulting figure here would be a circle. Okay? If I look at number 13 and I were to cut it, this resulting figure here would be a rectangle. And this cross section here, if I sliced it, would be a 1, 2, 3, 4, 6-sided, so a hexagon. And number 16, if I cut this crossways, the resulting shape is going to be this triangle. Let's look at 17. Now, look at this cross section. So this cross section is going to be a triangle. If you split a cone in half this way, the cross section is a triangle. And if you split a cross section this way, it's going to be a rectangle. And number 19, if you split it this way, it's parallel to this figure up here, which is a trapezoid. Number 20 is going to be a circle. Right? Number 21, if it ever comes into view, it is going to be, look at the figure that's opposite. So on 21, it's going to be a rectangle. And 22, it's parallel to that circle. Okay, so that's what a cross-section means of a shape. If you're struggling with the naming or how to see the cross-sections, come and see me.